Should I start? So, in this lecture, we will start a sort of new topic which is called two-port network. Now, any network, for example, and RLC network, RLC, any network, it could have other combination of impedances. I just to give you the idea. You have to excite this network with some input signal, and suppose I am interested to know what is the current. Then this network, these are the two input terminals, and you excite it with current or voltage sources and find out the desired output, either current or voltage across the inductance, what not. Now, this sort of network is a one port network. You excite it and maybe your current is the output. So, but what is a two port network? A two port network will, as a black box, first I draw, will be a network where two terminals will be available for input terminals across these two terminals you connect the input voltage source or current source, and across these two terminals you get the output. And often this input and output this thing will be shorted. For example, a network like this. For example, a network like this. I declared that these two are my input port, input port, input port, and these are the output ports. And there are impedances in between. No sources should be present in this. Often this is the case. For example, in a transmission line, you excite the transmission line from one end, there will be network impedances, line impedances coming in between, and at the output you receive the voltage with respect to same common point here. So, first let us try to analyze a two port network from this perspective, that is, there will be a distinct input port and output port, and the convention is very important. What they say is this, that in this input port the voltage across this is, I will always write with this polarity plus minus, and current drawn by the circuit network. So, two port network is I 1, this is the input port, and these two are output port, where the voltage of the output I will always mention with V 2, and its current direction I will specify it like this, because I told you several times that direction of current, in which direction it flows, I will assume it. So, it is the convention always in a two port network, except ABCD parameter network, that will come later, to assume the direction of voltage, polarity of the voltage and the current in the input and output port in this way. This is how we will specify, because we are now matured enough to understand the direction of the current, otherwise one can assume in any way one likes. And also remember, although I am writing V 1 I 1, V 2 I 2, they may be V 2 S, V 1 S, I 1 S, I 2 S. This S I will not continue to write, and the impedances here can be resistances or inside this two port network several impedances will be connected. They may be Z1s, Z2s, etc. So, that we will not go on writing S. In general, that is true, because in S domain if you write, you will get the response of the network for a given input, both for transient and steady state, things like that. But anyway, first thing is, this is how the input terminals, what is the thing? Inside there is should not be any source. All elements are linear elements inside this two port network. Okay. Now, what people do is this, they try to relate this V 1 I 1 and V 2 I 2 in some algebraic form of equations. For example, I will say that this how the voltages V 1 can it be expressed in terms of the currents, that is Z 11 I 1 plus Z 12 I 2. Similarly, V 2 I will say it is equal to Z 21 I 1 plus Z 22 I 2. See, as a matter of fact, this two port network, only thing I am told, they consist of linear elements and have no source inside, and there is maybe a common point. This is V 1 and this is V 2, like that. With respect to this point, these voltages are measured, and this is I 1, and somebody is telling also assume the current to be I 2 in this way. And we try to relate the input voltage and current with output voltage and current. So, as a black box if it comes, what I am telling is this, it is possible to relate the input and output voltages V 1 and V 2 to I can express them in terms of currents of input port current and output port current. And this can be written also in matrix form like this. Is it? So, this is one way of connecting the voltages and currents of input and output ports. There will be several other ways. Why I have written Z here? Because it looks like left hand side dimension will be in volts, I is ampere. So, it must be in ohms. These coefficients of I 1, I 2 must be in ohms. So, that is why I have written Z, impedance. So, that you know the same unit it must give from of the left hand side and right hand side. So, if a network is given in the form of a black box, I do not know Z 11, Z 12, Z 21 and Z 22, but I know perhaps they can be expressed, these voltages V 1 and V 2 in this form. Then the question is how to get these values of these impedances. How much is Z 11? How to model this two port network in this fashion? That is, in that case I must tell that Z 11, Z 12, Z 21 and Z 22 must be known, then only useful utilizations of these two equations can be carried on, otherwise how. So, the question is how to find out Z 11 by doing simple test of a given two port network, the inside of which you are not allowed to see, can be done in this way. Let us see. For example, Z 11, I will go slowly, so that you really understand this. I can write it as V 1 by I 1 with I 2 equal to 0, is not? What does this mean? Take this network, excite the input with a current source, keep this the I 2 equal to 0 means what? Output port open circuited. Let me write output port, do not connect any impedance. So, this current I 2 will be 0, you will be maintaining that such that I 2 is 0, I 2 is 0, and excite this with a current source I 1. This is the input port, and measure the voltage existing between these 2 points, that is V 1 as per this. Then ratio of V 1 by I 1 with I 2 equal to 0 is Z 11. That is the first equation I have utilized with I 2 equal to 0. What other parameters can be found out from this with I 2 equal to 0? Z 21 can be found out. Z 21, this first column elements Z 11 and Z 21 can be found out with making I 2 equal to 0, and Z 21 will be equal to V 2 by I 1 with I 2 equal to 0. That is, if you excite the input port with a current source I 1 and these 2 output ports are kept open circuited, which will ensure I 2 is equal to 0. Therefore, the thing will be V 11 with I 2 equal to 0. What are this equation? V 1 is equal to Z 11 I 1 and V 2 is equal to Z 21 into I 1. This is the thing, this is 0, 0. Therefore, I say that Z 11 you know it is V 1 by I 1 with I 2 equal to 0 and Z 21 is V 2 by I 1 with I 2 equal to 0. Got the point? Therefore, although a 2 port given network, these parameters can be found out by doing simple test. Excite this with a current source, note down this voltage. Now, you can easily see that how to find out Z 12 and Z 22. Is that clear? These 2 elements we have found out. How we have found out? I have told you excite this with a current source, get this, measured this. So, to calculate Z 21 you have to measure this voltage with a voltmeter V 2, open circuit voltage V 2 by input current I 1. I 1 is known. So, this is how Z 11 and Z 21 can be measured. It is very easy to see. To how to calculate this, I will write with red ink. Z 12 should be what? Come to this equation. Z 12 I can write V 1 by I 2, V 1 by I 2 with I 1 equal to 0, is not? And this element also Z 22 should be V 2 by I 2 with I 1 equal to 0. So, which experiment I have to perform to know these 2 parameter values in ohms? So, this was this experiment I did to find out Z 11 and Z 21. Now, I say that I have to also calculate Z12 and Z22, then this 2 ports network description will be complete. And I find that Z12 will be V 1 by I 2 provided I 1 is 0. Similarly, Z22 will be V 2 by I 2 with I 1 equal to 0. So, next I do this experiment. What is that? This below quantity is I 2. So, you excite this network with a current source from the output port I 2 in this direction and keep the primary open circuited, that is input port, I am sorry, input port open circuit. So, that which will ensure I 1 equal to 0 open circuit. And Z12 is and measure this voltage, that is V 1. There will be voltage existing, although it is open circuit. And I say that okay, then your Z12 will be this voltmeter reading V 1 divided by the current with which you have excited the output port with I 1 equal to 0. That is, this side is open circuited, excite this with a current source. And what will be Z22? Z22 will be with primary open circuited, I 1 equal to 0 you must specify. This is Z22 is V 2 by I 2 with I 1 equal to 0. So, primary, that is input port is open circuited. I have excited with I 2, then I will measure this voltage as well. This voltage will give you what? V 2. So, this voltmeter reading divided by this I 2 will give you Z22 with I 1 equal to 0. So, all the 4 parameters can be obtained, provided this network is a good candidate, so that it can be represented as a 2 port network. What should be the values of Z11, Z12, Z21 and Z22 by doing simple experiments, open circuit, keeping this port open, exciting this port with a current source, you get 2 parameters. Similarly, excite from this side with a current source I 2, measure the voltages of input and output port, you can get all the parameters and then you will be happy. Okay. Then you say that V 1 in general is Z11 I 1 plus Z12 I 2, Z21 I 1 plus Z22 I 2, all the parameters are known. And as you can see, the dimension of these quantities are known. So, this matrix, the parameter value, it is called the Z parameters. So, this 2 port network, this popular method of representing a network like this are called Z parameters of the network. Z parameters are nothing but open circuit condition parameters. You have to, while finding out this parameter, you have to keep the other port open, then only you can get these values, as I have elaborated here. Is that clear? So, in a 2 port network, when the voltages are expressed in terms of currents, you will be getting what is known as open circuit Z parameters. Why that open circuit business comes in? Because to measure those parameters, you have to keep other port open and excite the other port with current sources, that is all, and measure the voltage and current. So, this is how a 2 port network can be described, that is, I rewrite here B 11. Now, after knowing those things, I will use it. Now, I will say that okay, I have found out these parameters, then you know your input voltage, input currents are related by these algebraic equations. Mind you, these are algebraic equation. If it is in S domain, B 1 S, B 2 S, Z 1 S, Z 1 2 S, and so on. Everything will be in Laplace domain then also that is true always. So, this is the Z parameters of a two port network. Okay. Now, there is another way, there is no restriction. Somebody says that I want to express for this two port network. So, two port network remains same network, two port network. And as I told you, I will always express the terminal voltage and current with this polarity. This is the convention, with this I am doing. Same two port network, is it possible to express current in terms of voltages? For example, I will say that I would like to express I 1 with some constant into V 1 plus another constant into V 2. That is, the input current is linearly related with input and output voltages. And obviously, if you do that, the dimension of this should be admittance. What is the dimension of Y 1 1? This side it is ampere, this side it is volt. Therefore, this coefficient must have an dimension of mho, that is 1 over ohm. And this quantity I will write it as this. Similarly, I 2 perhaps can be expressed in this form, Y 2 1 V 1 plus Y 2 2 V 2. Therefore, in these expressions, same two port network I am talking, one could also say that relate the input currents with the input and output port currents with the input port voltage and output port voltage. Now, once again, what are the values of Y 1 1, Y 1 2, Y 2 1 and Y 2 2? You can easily see Y 1 1 will be equal to I 1 by V 1 provided V 2 is equal to 0, is not? So, suppose I will draw the network now like this two port network. What it says that V 2 is 0 means you short circuit this, then only V 2 will be equal to 0, is not? With V 2 is equal to 0 short circuit, you excite the input port with a voltage is below. So, excite this input port with a voltage V 1 and see how much current it is drawing I 1. And you know Y 1 1 then will be the ratio of this current. So, connect an ammeter or whatever it is measuring the current. So, I 1 by V 1 is to be the admittance Y 1 1. Which other parameter can be found out by doing this experiment? V 2 is equal to 0, that means these two terms will be absent. So, I can find out the first column terms Y 2 1, which will be equal to I 2 by V 1 with, do not forget to write V 2 is equal to 0. That is, you short circuit the output port, excite this with a voltage source. Whether I should excite it with a voltage or current source depends upon which quantity comes below. In the previous example, it comes that Z 1 2 for example, V 1 by I 2. So, I say okay, I will excite the other network with a current I 2 like that. So, I excite this with V 1 volt, keep this V 2 is equal to 0. Then what will be the relations? Now, I 1 is equal to y 1 1 V 1 plus 0 under this condition for this network, same two port network, and I 2 will be is equal to y 2 1 and V 1 plus 0, because V 2 is 0. Therefore, ratio of I 1 by V 1 with V 2 is equal to 0, and y 2 1 will be I 2 by V 1 with V 2 is equal to 0. These two parameters you will get. These are called admittance parameters. Okay. Similarly, you now know better than me, perhaps if you are following me truly, then I will also say this is okay. What about y 1 2? How to find out this parameter? Y 1 2 can be written as I 1 by V 2. It will be indeed I 1 by V 2 provided V 1 is equal to 0, and y 2 2 will be I 2 by V 2 with V 1 equal to 0. So, which experiments will give you these parameters? You have to then think that okay, this is the two port network, V 2 is below. So, I will excite the output port with some known voltage. So, V 2 I will connect, and V 1 equal to 0, V 1 I will short, V 1 equal to 0 I will short, and then this current, please forgive me, I forgot to mention this direction of the current, but it remains same. This y 2 1 is this current you must find out I 2 by this V 1. I think I just missed this I 2, because the direction of the current is what people all over the world has decided to be like that to describe a two port network. I mean, no point in fighting with the fact that why not I 2 you assume like this. And we know in a network direction of currents or polarity of the voltage, it is up to you to choose. So, anyway, we will follow this one where worldwide people follow it. So, I 2 is this way. So, you measure this current. So, I 1 by V 1 etcetera. So, in this case also you show these currents whenever you show it is like this. So, what is y 1 2? So, in this way if you connect the circuit, what this equations gives? This equation will be I 1, since V 1 equal to 0, this will be 0, 0 into y 1 1 plus y 1 2 into V 2, and I 2 since V 1 is equal to 0, 0 plus y 2 2 into V 2. So, with this input port shorted, apply a known voltage, measure this current, and your y 1 2 will be the ratio of this current with this voltage, applied voltage. Y 2 2 will be this current I 2 divided by this voltage, and therefore, all the four admittance parameters can be found out. Is that clear? So, this is the thing, and this obviously can be written in this form, in a matrix form, in a compact matrix form like this, that is y 1 1 V 1 plus y 1 2 V 2 divided by y plus y 1 1 y 1 2 y 2 1 y 2 2 and V 1 V 2. That is the same network which we found out Z parameters can be also expressed in terms of admittance parameters. Is not like this. Earlier, so these are called Y parameters. And how to know the Y parameters? You have to do some short circuit. So, sometimes they are called short circuit Y parameters. And for impedance, earlier we have got voltage you try to express in terms of impedances, and this will be I 1 I 2, is not 2 by 2 matrix. And it looks like there will be a relationship between these two. Why not? Because after all, you see from this equation, this is the Z matrix, this is true, na? Multiply with Z inverse, Z 1 2, Z 2 1 and Z 2 2. Inverse, multiply with the inverse of the matrix, pre-multiply both the sides, this into V 1 V 2, this will then become an identity matrix, is not? On both sides you multiply with the inverse, this one into this. So, inverse into the matrix itself is an identity matrix, and this will be equal to simply I 1 I 2. So, it looks like this Y parameters and Z parameters, if you have found out the impedance parameters, Z parameters, Y parameters, for that no extra test is to be done, but its inverse has to be found out. But we will see later, all the time this inverse may not exist, those things will come later. But today, therefore, what I have told is that any given 2-port network, the idea is first this convention, there will be input port where voltage and current, voltage polarity and current directions should be specified like this V 1 I 1, and there will be a definite output port terminals where V 2 and I 2 will be also specified, and the directions of the currents and the polarity of the voltage, I will always stick to this. And then I told you that okay, this 2-port network, whatever may be inside means there should not be any source, that is for certain, only impedances are present. Then it is possible to express input voltage in terms of input and output port voltages as a function of input port and output port currents, or vice versa. Input and output port currents can also be expressed in terms of voltages. There are other ways, for example, H parameters, hybrid parameters also is possible. Okay, and those things will, and also I will discuss in the next class. Thank you.